Hello guys, welcome to LeetCodes, and in today's video we will discuss LeetCode question 35 that says search insert position. So yeah, here we are given one sorted array of distinct integers and a target value, and we need to return the index of its target is found, and if not then return the index where it would be inserted. Okay. So yeah, and also we need to write an algorithm in big of log and time runtime complexity. So there is one specific algorithm to solve this question and to write the code in big of log and time complexity, and that is binary search. So yeah, in today's video I will also explain this below underlying algorithm, that is a binary search, in what type of question you need to use binary search and how the binary search works. So after going through this question, we will first discuss that why binary search will work here and how it works, right? So if you don't know how binary search will works, then yeah, you are at the right place. I will explain you that also in this video. So make sure you watch the video till the end and hit the like button. So yeah, starting from understanding what this question says is that you will be given one nums array, and it will consist sorted arrays of distinct integers, right? So no numbers will be repeated and the given arrays are sorted. Further, you will be also given a target value, and you need to find the index where this target value will be inserted. So here, as you can see, this target value is 5, so it will come after 3, correct? This 5 can't come after 6 because we need to keep this nums array sorted, so it will come after 3, right? So after 3, what is the index? 2. The index is 2, so the first index where this 5 can be inserted is this index 2. Okay. Now here the target is 2, so 2 can be inserted after 1 but before 3. So yeah, the index where 2 can be inserted is index 1, so that is after this number, that is number 1, that is at index 0. So we can insert somewhere here between 1 and 3, so it is index 1. So now in this third example, that we have a target 7, and you first think where it can be inserted. See, we cannot insert target, that is the number 7, anywhere in between. Okay, so we have to insert after 6. So yeah, we return 4 as our answer because this is the last index, that is index 3, and we have to insert 7 after this index, so that is at index 4. So yeah, that is our answer here. So see guys, that whenever you have something like this, the input array is sorted and you are given something target value, then in that case you must think of doing what? You're doing binary search. Why binary search is better than other? So see, if you traverse all these nums array, so let's say you have nums array like 1 2 3 5 8 9, and if you have to insert let's say 7, then what you do, you traverse from 1 to 2 to 3 to 5 to 8, and then you found that yeah, 8 is greater than 7, so you stop. So here what would be the time complexity? Time complexity here is big of n. Why big of n? Because you need to traverse all the numbers, right? All the n numbers present in the array. But this binary search algorithm will give you the answer in the time complexity big of log of n. So this big of log of n is very less than big of n. Okay. So yeah, that's why we need to use binary search. Got it? And whenever you have something like this, that is the input array is sorted and you have some target value, then you must think of applying binary search. These are the hints, you can say the intuition where you can form of binary search based on these hints, correct? So yeah, now let's take a look at what is binary search and how it works. So binary search is an algorithm to find a target value. Let's say let me take k is equal to 5 as the target value in the sorted nums array. See, it only works in the sorted nums array. So yeah, this is the sorted nums array, right? And we need to find the index or the position of k equal to 5. So let's consider this situation, okay, that this is the target value and you need to find the target in the nums array, correct? So in this case you can use binary search, and let me show you how it will work. See, binary search has two variables, low and high. Okay, so let me write here is low, high, and one mid. So if low is 0, so initially the low is 0, that is the lowest element or the lowest index here. So it's low is 0, high is 6, the highest index, 0 1 2 3 4 5 6. 6 is the high. So based on the low and high, what we calculate mid. So what is mid? Mid is nothing but high plus low by 2. Okay, so here the mid is 3. Okay, so yeah, we check if the mid element, so in order to find target value 5, so this is the target value 5 in this nums array, index of this target value, we check that if the mid element, so that is the element at index 3, if it is greater than this target, then we move left. If mid greater than target, then what we do, we move left. Mid less than target, we move right. And if mid equals to target, then that is our answer, right? That index is our answer. So yeah, what is this move left and move right? I will tell you. So here let me again give this an index. So here what is our mid? Our mid is index 3, that is this is our mid. Now as you can see here that mid is less than target, right? Target is 5, number 5, and mid element is 4. So mid is less than target. So that means that your element 5 won't be present in this, will never be present, right? So we may move towards the right, because your element will never be present in this all the numbers before this mid. Okay, before this mid it won't be present, correct? So we move towards the right. Now move towards the right means what? We just updates our low and high, this pointer, low pointer and high pointer, we just update low and high pointer, and we make low here and high will remain as it is. So in that case what we do, we make low equal to mid plus 1, correct? And in this case if we have to move left, then we make high equal to mid minus 1. These are the changes that we do, correct? Okay, so yeah, now the new low is index 4, the new high is index 6. Now again see, now the low is index 4, high is index 6, and now what is the mid? Mid would be 6 plus 4 by 2, that is 5. Now mid would be here, somewhere here. Now as you can see, now what is the condition? That mid is greater than target, then we move left. Move left, that means high equal to mid minus 1. So we make high here, this value or the index 4, because our answer won't be present here, right? So we move towards the left, because all the numbers beyond this is greater than target, correct? So yeah, we move towards the left. Initially we move towards the right, then we move towards the left. Now both low and high are at this position, right? Index 4, low is 4, high is also at index 4, and if you try to find mid, that would be also 4, correct? And this condition, that if mid equal to target, is got hit, this condition is hit, so we found our answer, that is index 4. So we found our answer, this condition get triggered, correct? So yeah, this is the typical binary search, how it works, that we have 2 pointers, low and high. We just check the values by using if else condition, that if mid is greater than target, or mid is less than target, or mid equals to target, then yeah, in this type of condition we simply do some changes of the pointers, and if we got our answer, then we simply return the index. So yeah, I hope you guys understood that how this binary search works, that instead of checking each element, we simply directly jump from here to here, then we jump from here to second mid, then we got our answer. See, in the 3 jumps only we got the answer, correct? Only in 3 jumps. Whereas if you would do for loop of big of n time complexity, then you will take 1 2 3 4 jumps, but yeah, here we reduce, correct? So this is how the binary search works. And if you have like n, let's say 10 to the power 9, this much big array length, so in that case what will this work? No, this won't work, right? This normal for loop, you only have to do binary search, that is log of n, log of 10 to the power 9. You have to do this only. Normal for loop won't work. Okay, this is not very good approach. Okay, it might work, but it is not the best approach. Got it? This is a very better approach, or with a better time complexity. So yeah, I hope you guys understood the binary search, how it works. Now how we can apply this in our question. So what our question says is, our question says to insert a number. What it says, insert number and at a position, and we need to return what? We need to return this position. So let's say you have something like this, 1 2 5 6 8. Okay, and let's say in this, if the target is, let's say if a target value is, let's say 4, so where you can insert 4, it is obvious that you have to insert 4 before this 5, before the 5. So you will and after this index 1. So yeah, what you will return for to insert for, you will return index 2. So this is index, see, not the value, but it is an index. So you have to insert after this one, correct? So let's say in this array, instead of 4 you have something like this, 9 as a target. Then where you will insert? You will insert after this 8, right? 9 will come after 8, correct? So that's why we would return 5, that is at index 5, correct? So let's say if you have to insert -1, where would -1 come? It would come before this one, right? Before this one. So you will write 0. But yeah, one thing to note here is that so you can say that target can be also negative. So yeah, previously we have to insert, correct? So yeah, that's correct answer, that is an index 0. So I hope you guys understood the question, that what we are doing here is we need to find one index whose previous values are less than target and whose next values are greater than equal to target. Okay, why greater than equal to? So if you had something like target 6, then where it would be inserted? After 5 but before 6, right? So we would return index 3. So I wrote this condition that we need to find such index whose previous is less than target and whose next element is greater than equal to target. We need to find such index as our answer, correct? So yeah, this is what so to achieve this, what we will do, we will simply do binary search. So we will let me show you how we will do binary search, okay, directly by the code. So yeah, here is the code for binary search. So as I have told you earlier, that in binary search we took two variables or two pointers, the low and the high. So yeah, similarly I took two pointers, low and the high. Then we calculate the mid. Mid is what? High plus low by 2, correct? Mid is high plus low by 2. And then we check that if nums of mid is greater than equal to target, then these are some of the conditions to return our answer. And in the else, what here we are doing? We are doing what? High equal to mid minus 1, that is move left, and low equal to mid plus 1, that is move right. See, this condition are here. We mid is greater than target, then we move towards the left. Okay, mid is greater than target, then we move towards the left. High equal to mid minus 1, and mid is less than target, then we move towards the right. Okay, this is moving towards the right. Got it? This same binary search we are doing here, but with simple adding few conditions, right, in order to solve this question. So let me take one example here for a dry run. So let us take this example itself, that what we are doing here, and I will try to make you understand. So if you have something like this, 1 3 5 6, and the target is here 5, and we will also give low, high and mid. Okay, so initially what is the low? Low is 0. What is the high? High is 3. See, let me give you also index. So this is index 0, index 1, index 2, index 3. High is index 3. What would be your mid? High plus low by 2. So that would be 1 here. Now do you check with number with index 1. So this is 3 is greater than 5. No, this condition is false. So we will come to else. Is 3, because the 3 is less than 5. So we do this, low equal to mid plus 1. So we make low to 2, high will remain 3 in the next iteration. So here what is now mid? 3 plus 2, that is 5 by 2, it's 2. Now we check. Now here this is the 5. So this condition is satisfied, that nums of mid, that is 5 is greater than equal to 5, right? 5 greater than equal to 5. Now this condition, if mid equal to 0, that means why we wrote this, why I wrote this condition. Okay, so if you have 1 3 5 and 6 as num array, and the target is, let's say, 1, then in that case this mid would be at index 0. Mid would be at index 0. Okay, or if you have something like, say, -1, then also this 1 is greater than equal to target, and this mid equal to 0. Then where we have to insert all the numbers that are less than equal to this starting element has to be inserted as the index 0, correct? That's why we return 0. Now in the second case, if nums of mid minus 1 is less than target, that means we have for here we are inserting what? We are inserting this 5, and the previous element is less than target. As you can see, the previous element, what is this? This is the previous is less than target. So this is the correct position. Okay, so this is the correct position, right? So that's why we return mid. Here also we are inserting 5. So the previous position is less than target, and the current position is greater than equal to target. So this after this previous position, that is the current, the mid position is the perfect, so we return mid. Yeah. And yeah, if you and if this is the case, that and in the else condition, what is the else condition? That let's say if you have to insert, so let's say if the current mid is 5 and you have to something insert like let's say you have to insert something like say 2, then what in that case what we have to do? We can't we there is no need to move backwards, right? We move towards the left. This is move towards left, simple as it. This is a simple binary search condition, and this is move towards right. Got it? So yeah, this is how this complete binary search works here, that we move towards the left or right, and we found any condition that if it is matching the target, let's say that is equals to target, or the previous element is less than target, then in that case we simply return the mid, the current index. So yeah, that's all for this video. I hope you guys understood the complete approach, that why binary search works here, how binary search works, and why it reduces the time complexity. See, initially you have to traverse all the elements in order to insert and find the position of the target, but using binary search you can only make a few jumps and reach to that answer. So yeah, that's why we use binary search here. Not talking about the time and space complexity. The time complexity, as we've already discussed, is big O of log n, log of n, and the space complexity is just simply big O of 1, since we are not storing anything, and which is a simple variables, we are not storing anything, and that's why the space complexity is big O of 1. So I hope you guys understood the complete question, and if you have still any doubts, then do let me know in the comment section. Make sure you like this video and subscribe to our channel. Thank you.